Passing the other. Then shut down with Ramiro. Oh, you say that I'm thinking of my own. I got a how they are done. So hard in my it was a
Okay, students, wish you a good morning. Right. We'll start this lecture session on 8:30. We have to start on time and finish on time. Right? 8:30 is the time we start. Therefore, keeping in that, let's start. And I don't know why you should on day. I think some people come from far away areas, but they are on time. But on the other hand, we cannot wait. And despite telling that the importance of attending lectures on time, so this lecture is supposed to start at what time? 8 a.m. So we are waiting 30 minutes. So it shows the part of students. Disregard policy proceed. Therefore, we cannot tolerate that kind of things. And if you are tolerate that, then we are doing the kind of bad practices. Bad practices, we should not allow bad practices. We should always promote good practices. Punctuality, taking part on time, those are things that are good. Yes. So, if we don't keep up with that, those good practices or companies, when you start work in organizations, you'll be doing the same. Right? And that might, once start delayed for your employment, for your job, it might be the first day itself, you might be fired. Or then the other way. So, I don't think that how the company get it going on. I don't think anyone would like to go home on the day itself. Therefore, what we do is we start on time and we finish on time. Right. So with that, good morning to all of you. Very happy to see you all again after the Friday assessment that we had last. And we regularly have assessments. Right. So that will be a daily practice. Okay. So what was the thing that we asked for the so what was the assumptions that we do? No, that's right. So that's the last we can be confirmed from. National says it's no about 1 million. How about 1 million? Exactly. No about that's right. So confirm. We did confirm from. So the students who are taking notes more than that, really have to see it. Others don't take it. No, again, right. So thank you for that information. So we discussed what the substance taking in confidence when it comes to preparation. And today we are going to discuss another three assumptions. We are going to carry forward our discussion, right, related to the assumptions of oil execution, already discussed. So we are discussing them, right? So please open those documentation. Okay. So let's see what are the assumptions we discussed, which I revised last week as well. But again, now let's carry forward. So go to the limits. Let's go to the limits. Okay, in this LLs we have several information. Okay, so we are now in regression analysis. We discussed about correlation, we discussed about regression, descriptive statistics, correlation, regression, and now we are dedicating to regression assumptions. You can see there is this file under week 6. You can see there is regression assumption checklist status. So please download it, which you already should have done it. But again, please download that. Checking regression assumptions. If you have not already done so. And please open this Word file. I have already opened that Word file. Okay, this is the Word file that we should have opened. So we are checking the regression assumptions. So first of all, you have to download data session 3 survey 480 data file. So please open that file and run the regression like this, where the independent variable and the dependent variables are provided. Right. So let's go through that. So session 4 survey 480 is this file. So please download and open this file. So it's in the LMS, you can see session 6 under week 6. Week 6, session 4. You can see this is the Word file that we should open and that we were using. And we check 3 regression assumptions. Right. And then status session 4 is the PowerPoint that we were using, not that. Then download status session 4 survey 485 and open it. Survey 485. Please download it and open it. It's session 4, survey 480. Right. So once you open a file, please check the contents of that file. That's the best practice. And you browse and check whether the contents are there. Yes, it seems the contents are there, right? Seems the contents are there. Perfect. Now, so you have followed the first step. You have opened the Word file. You have opened the Word file. That's first step. Zero step and step number one. You have loaded the data set. Session 3 or session 4 survey for it. Is it open? Is it open? Right? Everyone fine? Right. Next thing, what you need to do is you need to run the OLS revision. You need to run the OLS revision or OLS classification, where it clearly says the dependent variable is total life satisfaction. The independent variables are age and total perceived stress. Right? These are the two independent variables. So shall we now run the regression analysis? So I will open Magnify as well. So we will magnify it. Okay. Right. So let's go to data. First open the data file, then edit. And now let's run the OLS regression. To run the OLS regression, what we need to do is we have more statistics, then what? Statistics. Linear noise and related. Then what? Linear regression. So go to linear regression. And then now please select the independent and dependent variable. The dependent and dependent variable. You can see the dependent variable is what? T life set. Not life set. T life set is the dependent variable. And there are two independent variables, age and what's the other one? Age and stress. TB stress. Go down, down, down. What is it down? Then you have TB stress. Total percent stress. So total life satisfaction, age and stress are there. Right? So these variables are T life set, age and TB stress. And press OK. And then you run the regression. So these are regression outputs. Right. Okay. Is the overall model significant? Just asking a few questions. Is the overall model significant? Yes. You can see here. This is less than 0.05. The F test indicating the F value is 69.58 and the significance value, the P value, the probability is less than 0.05. In that case, you confirm what? Whether the overall model is significant or not. Yes, it is. So that's a good sign. And what's the explanatory power of the model? What's the explanatory power of the independent variable? Yes, I'm getting the answer. What's the explanatory power? 24.45. What does it mean? 24.45% of the variation of the total life satisfaction is explained by the two separate independent variables, age and stress. Age and stress would explain 24.45% of the life satisfaction. Right. Then now you have the two independent variables. Are those individually significant? Model like a significant fine. That's right. The model is overall significant, right? But whether the independent variables taken independently, is it significant? No. You can see age here, the B value is less than 0.0. It's more than 0.0. Not less than. It's more than 0.05. So in that case, can we call age a significant predictor? You can't. Age is not predicting what? Not significant predicting what? Life satisfaction. But other than how about stress? Is it a significant predictor? Yes. Stress is less than 0.05. In that case, it's a significant predictor. So this we understood. Right? And then we started now checking the regression assumption. You will check the regression assumption. Let's look at it. So the first assumption is what? What is the first assumption? Linearity assumption. What does the linearity assumption say? That the independent variable and the dependent variable should be what? Linear. Having a linear relationship. And to check that, what do you do? What are the To check the linear relationship, what do we do? We view scatter plot diagrams, and we check visually whether there are linear relationships or not. What did we see? What was the outcome? When we took age and life satisfaction, we drew a scatter plot diagram for that two variables, right? Age and for life satisfaction. What did we see? Did we see a strong linear relationship? No, we did not see. Then what we did was, we went to the next one. What's that? We took stress, perceived stress, and total life satisfaction. We drew a scatter plot diagram. What did we see? We saw rather stronger linear relationship than age. So therefore, we concluded part. This particular assumption is partially satisfied. We cannot say fully satisfied because age does not have a quite strong relationship, linear relationship with the life satisfaction variable. But on the other hand, perceived stress has what? A quite strong linear relationship with the life satisfaction variable. So that's why we call it is partially satisfied. Partially. Then second one. The second assumption is no multi-polarity. What do we mean by multi-polarity? Multi-polarity means the independent variables having unnecessarily strong relationships. Unnecessarily, I will use the term unnecessarily because if the correlation is above 0.8, that shows there's a quite strong correlation between the independent variables. Now here, what are the independent variables? By looking at the equation 10, what are the independent variables? We have age as well as we have stress. Age and stress are there. So here we don't expect them to have strong put. Now, of course, age and life satisfaction, the dependent variable, we expect to have a strong relationship or strong impact. Stress and life satisfaction, yes. But we are not expecting age and stress, the two independent variables, to have a strong relationship. Right? So that's what we call, if you do have age and stress have a strong relationship, we call it multiple. And here the assumption is that no multiple is there. So I told you that there are two methods that you can follow to check multiple. Method number one is what? What's method one? M1. What's M1? What's method one? What's method one? Very good. Sir. Method one. Method one. Very good. I was asked using correlation analysis. So I thought by performing a correlation analysis between age and stress, you can see whether it's above or below 0.8. If there is a significant correlation above 0.8, the correlation coefficient, then you would say there is a possibility of what? Having one form. Okay, there's a possibility. Then what's the do? Let us do it. Okay, now the answer. Okay. Very good. Well, BIF. BIF stands for what? Variation. What? Variance inflation factors. BIF. Right? Variance inflation factor. BIF factor. I told you the BIF factor should be less than what? BIF factor is given. Ideally, if it is less than 5, that's best. But again, at least if it is less than 10, then that's right. So that's what we understood. And in this case, what you can see, it is a high correlation and with the not. With the bonding capacity high correlation and no, we did not see. We did not see high correlation. We did not see high correlation. And the real effect, of course, the real effect. Real effect is real effect is what was the real effect? It was less than 5. Less than 10, less than 5. So it's double. So less than 5 centimeters, but less than 10 somebody. 5 so therefore considered as a very good point. A very good point. So, right. So there is no multi-point. We did not see any multi-point in the day. Because the age and stress are not highly important. Right. So this method 1 and method 2 is easy. And method 3 is no autocorrelation. What's autocorrelation? What autocorrelation? Autocorrelation is what? The observations is to be independent. If there is autocorrelation, then the observations are unnecessarily correlated with each other. Observations need to be independent. They should come from independent people, independent companies. Observation 1, 2, 3, like there are several 439 observations. These 439 observations need to be independent from each other. If it is not independent, then yes or not? Now take the autocorrelation issue. What does this say to follow? That's not an answer. No. What is this that you go? 30% test. Right? You have to perform 30% test. Compound. 30% test. And we understood the 30% test should be less than what? Come on. You know what I'm doing? Right? You know what I'm doing? Oh. Right? It has to be allowed to. Not less than. To be allowed to. And it will be less than 1 or above. They are already. That's what we discuss. That's 30%. 30%. Test parents. Right? 30%. Now let's come to the fourth test that we have to test. The fourth test is no outliers. Now, what are outliers? What are outliers? Outliers are observations that are significantly higher or significantly lower. Outliers are extreme values. If your data has, right, if your data is having extremely large values or extremely small values, those are outliers. Right? Outliers. Outliers will corrupt the analysis, will skew the analysis, will manipulate the analysis. Right? What are outliers? Outliers are significant observations, large observations. Now, for an example, right, if age, let's say for an example, there's a person, let's say, in our data set, having an age of 102 years old, anyone. While the average is 37, there is a person 102. In that case, what's that? It's an outlier. Extremely large or extremely small values are known as outliers. If you have outliers, what it will do is it will manipulate it to skew the analysis, to corrupt the analysis. So we need to ensure that there are no outliers. For that, we conclude something called the Cook's distance. What are again outliers? Extremely large or extremely small values in the data set. What's wrong with having extremely large or extremely small values? It will manipulate, it will skew the analysis. If you have extremely large or extremely small values. Outliers again, Shala, Vita, Pala, for an example, if you take the Sri Lanka listed companies, the ROA, let's say it's around 10%. Average ROA is 10%. But let's say there is a company that has an ROA of 2,500. Yes, there are some companies of that. Nobody saw. Is it an outlier? Yes or no? Yes. 10% is the average ROA of a listed company. But we have a company which has 2,500. And if you put that to the analysis, that will skew the analysis. Revision. Then there is another company, minus 1,000 is the outlier. Minus 1,000. Yes, they are not companies. Those are outliers. Extremely small, minus 1,000. So we need to treat these, we need to remove these outliers from one. There are other ways also to treat that. I'll teach you later, like visualization. We'll see that visualization will drop. But we cannot expect outliers in our data. Large values, very large values, very small values, we cannot talk. To check that whether there are proof outliers and proof basis, what we can do is we can perform what? A test called Cook's distance. Let's see how to do it. What you can do is to check the Cook's distance. So you have to compute something called the Cook's distance. Right? It has to be below 1. Cook's distance is equal. And the Cook's distance is right? Make a me, see the smoker, someone Cook's, is there something related to the kitchen? Kitchen negative? No. This was not one page. There's no any relationship. This particular value, right? The statistics was developed by a person called Cooks. Cooks distance. The person Cooks came up with this idea, right? The statistics Cooks distance. The value should be less than 1. 1 will not happen. 1. Okay. If it is above 1, then there is an issue. So how to calculate Cook's distance? Very simple. You copy this. Predict Cook SP and then comma Cook SP. You go over here. Want to run the regression analysis? Unless you run the regression analysis, it's not going to work. So first, on the regression analysis as I did here, then what you can do is you can say predict hooks. Right? You can see, right? Predict here, hook, SD, comma, hook, SD. Make sure that you have. So what it will do is it will create a new variable called hook SD. Make the comma, alt variable create hook SD. And it will have the distance for each observation. अब observation we have hook SD वाला एक जाता वाला it has to be less than what? Less than 1. So here that this is ठीक है. So just type predict hook SD predict. तो वहाँ आप दिया मैं predict hook SD. Right? And then what you can do is you can hit enter. Enter again. Then you can see a new variable is there. Here, if you go from the variable list, then the variable list. This is the variable. Just figure a variable there. Hooks key. Hooks key value is there. Now, what we need to see is hooks value is less than if there is any observation that's above 1. Check that we go to the data set. We go here and you can say browse, or you can say even edit, or here it's called edit. Edit command. Then you can see the data set. And go to the last column. When it hooks SD get all variable again. Let's see. SD get everything. Then you can right click, data, sorting. Right click करो sort करो. Right click while you are in the data editor. Right click, data, sorting. वो sort करना. और ना बैटरी में का ऑटोमेटिक की. So sort data. Hooks is the so standard sort that's good enough. And hooks is the that's the variable we have chosen. And you can press OK. Or you can see very small values are there. -8 can it's a very tiny value. A very tiny value. Then you go down. You can see for each observation, hooks is there. Is there any value that's above 1? You have to give 1. Next. The maximum value it seems hooks is 0.0311. Can you see that? 0.311. So there's no value that's above 1. There's no observation that having a hooks D that's above 1. Hooks D is above 1. If one of the put here. This is the sort command. I apply the sort command. Then you check that. Sort it. Sort SD and hooks D and basically see whether there's another way to check that also. What's that? You can use a summary command. You can say summarize. Summarize. Hook SD, hooks D. You can see here the maximum value is how much? You can summary command. Then the summarize hooks SD. You can see the maximum value is how much? 0.311. Right? 0.311. So there's already. Okay. Now, next thing what I will ask you to do is I'm going to ask you what exercise to be done. What exercise are they done? Right? Now do this exactly. Now do this in groups. And I'll ask you to then discuss that later. So these the exercise. You see the books as well as other solutions. So you go to okay, now these the exercise. Use the sample data file photo. Now open a new data session and open the auto DTA file and run distribution. How to do this? Open a fresh data session. Once data session you have opened. Or what you can do is even once you are having this one, you can type, right? If you want to use the same session. So better to open a new data session. I'm going to open a new data session. I'm going to go here and I'm going to go to this data. Here, data is there. I'm opening a new data session. And then what we shall do is we shall now open a sample data set. How to open a sample data set? I already told you that. How to open a sample data set? You go to file. Then what? Example data sets. File example data set. File example data sets. Make it already installed data sets is data. Data in a data set buckets, data set. Then you can see there are example data sets. Example data sets. So let's go to example data sets. Pick around they know this data. Data. Example data sets. Description data. Go to the description and you can see auto DT is there. Can see that. Auto DT is there and say use. Then it will open that data set. Use. Because when you make data set, it open. Now, I'll give you a shortcut. Go to the command and type sys system use. System make the other file auto. That's all. Sys use auto and hit enter. That also will open same. That's the shortcut. Sys use auto file example data sets. Then go to description example data sets installed state. And there choose the first one, auto DT. That's what you do. That's the command in DT. Same command you can see. This use auto. So you will open this page. Did you open that? Right? Now what we shall do is we shall run a regression. When the regression is good. Run dependent variable price. In this data set, what we have is price of all automobiles. Automobile in America price is dependent variable. Price is the dependent variable. The independent variables are weight and mileage. Independent variables. If the weight is higher, then the price of the car should be higher. Then mileage is price. So likewise, now run the regression. How to run the regression? You can go to what? Here price is there, mileage is there, and weight is there. Now run the regression. How to run the regression? You go to statistics, linear, what is simulated, linear regression. And then the dependent variable is what? Dependent variable what? The two independent variables are what? Weight and the MPG. And presso. Then there are 74 observations. And you can see weight is a significant predictor, but MPG, miles per gallon, is not a significant predictor. Did you run the regression? Everyone fine? Now check the four assumptions. The assumptions are check. Maybe the assumptions are check. Daily rating. Then what? Daily rating. What's the second one? One quality. Then what? Outliers. That's what we check. Then another one we check. What's that? No. I can't check four. Can you check now the four assumptions at groups? Don't you have another data set? So I think I will do about 10 minutes. It was our Srilanka was Canadian. Again, group. Check the four assumptions. I'm going to give you about 10 minutes. You can discuss, of course. Work as groups. I will never leave you. No need that we can be careful. Maybe they don't mean it. You get some of this on the it's a India made and I'm killing it. We just make it the best. I mean, it's very hard. So, it's more but it does.
Oh, đâu đến đâu cái không anh chụp tay sẽ đây cái này cái số chúng ta sao có lên cái đó ta tay sẽ cái gì thì cái số chúng ta không tay sẽ không cái số cái cái số đó thì như vậy sẽ có em phải làm cái bảo cái tiếng anh xong rồi làm quản rất là ô mình kiếm để cái sẽ có một ngày cái một ngày này là trong cái phim tôi vẫn thì em sẽ mua cái giải pháp rất là biết đó ở đây cái này thì tôi không phải sự để đây tôi support nó sẽ thì nó sẽ chúng ta sẽ because you know you don't 0.05. Data less than 0.05. Legal side responsible for managing equality already simplified. Because it's a less than 0.0.
Okay, all this. You look at it. All the thing. I see. And
Yes.
very well. Are you already multiple? How about here? Here. Substitute. Okay. Yeah, when you don't share the person, you have to most of it come up. Right, to answer the person, we have to start these two first. Okay, now let's see one by one how to run the regression assumption. These are regression name. To run the regression assumptions, again, let's go to the new story. So first assumption is what? Whether there's linearity, right? So there are two independent variables. What are the independent variables? The APG as well as weight. Weight of a car as well as mile per gallon per car. Right. So that's given. So what you can do is you can go to the correct regression. Go to the correct data and then draw two scatter plots. Graphs. Then scatter. Weight. Scatter is what we require. And the dependent variables are price. Sorry, X. Actually, X is the price. And no, not the price. Sorry, I'm correct. Weight. First is, let's say, weight and price. Weight and price. Right, weight is one independent variable, and the other one is the price.
accept it and see that one. And copy this picture to, yes, it seems not bad, right? There's a positive, it seems, but not that high, but not bad as well. Weight. Weight has somewhat a positive relationship. When weight goes up, then the price goes up. Then let's see the next one. Copy and paste that figure, right? The diagram into your Word file. Then let's go to the next one. Again, let's go to graphs, two-way graphs. And let's edit that. Edit. Now I'm going to have not weight. I'm going to take what? MPG, miles per gallon, and whether there's an impact on price. So I'm going to press OK, accept, and I'm going to press OK. Oh, that is there, but not strong. But it seems there is a kind of a negative one, but again, not a strong correlation. Not a strong correlation, but there seems a negative relationship, but not as strong as the earlier. So again, we can tell this assumption is partially satisfied. This assumption is partially satisfied. The linear assumption is partially satisfied. We can check. Right. Then second assumption is no multi-collinear. Right. So the first assumption you can say partially satisfied. The second assumption is no multi-collinear. Now check multi-collinearity. What's the analysis that you do? Multi-collinearity assumption analysis what? You have to test the different perform. Method one, correlation analysis. Right? To check this, you can check the correlation. How to check that? So you go to data again, go to the correct data, right? And you go to statistics, summaries, tables, and traces. And under summary and descriptive statistics, go to pair-wise correlations. Pair-wise correlations. And there we shall choose the variance. You can have price. No, price is not what we are interested in. You can have one. So two independent variables. What are the independent variables? Weight, and what's the other one? NT. So we are going to look at the correlation between these two. And don't forget also to think on print significant level. Print significant level के लिए ठीक करना पता करना Take that as well. And you can press OK. What kind of a correlation is there? A bit problematic correlation is there. 4.8 Lanka plus 28. 4.8 plus 10. But it's around 0.8, minus 0.8, weight and NTE. And it's significant also. So let's also do the second test. What's the second test? The VI test. How can you do the GI test? You go to statistics, linear models are related. You go to what? Regression diagnostics, and we go to what? Specification test. Right. Specification test. And there you have variance inflation factor test here. Variation inflation factor for independent variables is there. And I'm going to press OK. VF value is how much? 2.87. Is it okay? 2.87 के लिए क्या लिखा आपने? Yes, it's fine. Less than 10. Did you get this one? Well, your value cover. Here value cover. Can you raise your hand? Good, very good. So therefore, it shows that your VF value is also reasonable, although your correlation is almost 0.8, minus 0.8, but it's not above 0.8, slightly above, but again, it's not a big issue. With the second test indicates 2.87, there is no big deal in that. So that's good. So that's the second assumption we checked. No multiple. So that assumption is satisfied. Then the third assumption is no autocorrelation. To do that, you have to run the Durbin-Watson test. But to run the Durbin-Watson test, you have to first run these two. And the regression again. And the Durbin-Watson test. So, me, one. DW stat no. It won't work. First you have to create this. So how to create that? So first run this, copy this to generate time ID equals underscore n. Then T set time ID, right? And then run another regression. So I'm going to run this first. First run those two commands. Here I pasted them here. Then time ID underscore ID equals underscore n. T set time I. So hit enter. Now it identifies time ID as a time variable. And now run the regression again. Run the regression again. So statistics, linear modes and related linear regression. And yes, price is the dependent variable and weight and MTG are the independent variables. Now press OK and run the. So these are regressions. Now what you need to do is now go here and type DW stat and run the Durbin-Watson analysis. DW stat. Durbin-Watson statistics. DW stat. What's the value? What's the DW value? DW value clear? It's around 1.13. It's not below 1. It's not above 3 as well. Ideally, this should have been around 2. But I don't see a major issue because it's 1.1. But was this less than? Ideal situation should have been number 2. But again, it's around 1.1. No issue. No major issue. Anyway, no major issue. So here we can conclude, right? This assumption, right? Autocorrelation assumption is also satisfied. Major assumption is satisfied of the other. So assumption number 1, linearity partially satisfied. Assumption number 2, what's that? Assumption number 2, what? Multicollinearity satisfied. Assumption 3, autocorrelation satisfied. So no autocorrelation satisfied. This is the third assumption. Right? Clear? Then the fourth assumption is what? No outliers. Can you do this predict? So it's very simple. You just type predict. book SD, comma, book SD. Books D. So it would have created books D value. And if there are books D values above 1, you can use summary command, summarize, and you can say books D. Are there outliers? Are there? No, there are no any outliers. Why? Because the maximum value for this variable, books D variable, is 0.42, which is less than 1. The books D value is less than 1. So this assumption also is satisfied. No outliers are and no outliers. Right? So we check 3 assumptions. We check 3 assumptions. 4 assumptions. 4 assumptions. First assumption partially satisfied. And all of the assumptions are fine. Right? 4 assumptions are all. Now let's go to the 5th and 6th assumptions. How to take them? So the next assumption is a bit tricky. We have to understand this very clearly. Now pay your maximum attention for what I am going to explain. Now observe the balance. Please look at the screen very carefully. Because now I am going to teach you what's this particular assumption on. Constant of variance. Constant. The variance of the residuals are constant. That is our. But first of all, let me teach you what's a residual. First, let me teach you what's a residual, what's an error. Right? So you can see, now let's take an example. You can see this graph. Just scatter plot that. You can see the independent variables, hours spent on revising, and the exam marks. Revision hours that each student has spent, and the exam marks are indicated by each student. They have a dot in nothing. Hours spent revising and exam marks. If you again go and revise, the content will happen. If you go through the notes that you are taking, and if you are going through again and again the information that we teach you, what will happen to your marks? They will go up, isn't it? So likewise, here what has been graphed is these dots represent each student. A student's number of this particular student here has spent almost 30 hours and got an exam score 55 or something. 50. Likewise, each dot represents a student. A number of hours spent on revising the subject matter and the marks that person has got. Then what we do is, we draw this straight line. This straight line is known as the regression line. This regression line is drawn to represent the most of the lines, most of the dots. Right? It's like this. Here the independent variable and the dependent variable. Here you have the others, and here you have the marks. Then E dot represents the student. So in the regression analysis, what it tries to do is it tries to predict the line of misfit that fits the dots most. Can a line fit all these dots? If a straight line is good, they have not to have the correct current. But what it does is it can draw a line that represents most of the dots. This is what we call the OLS regression line. This is the regression line. OLS. Ordinary least squares. We are taking the least distance and we take a line that represents most of these dots. So it will be y equals alpha plus beta x. Right? This is what we are talking regarding regression. But however, you will understand there are some dots, the real dot is here and the line is here. So you can see when it comes to this particular dot, it doesn't really fall on this line. The student does not fall on this line, is it? So you can see there's an error between the actual value and the line. That's called an error. Because the exact key doesn't go, the line doesn't go on that particular student. Which student is doing. And here you can see this dot here. The actual line is here, but this student is here. So this is an error. Because this line does not exactly go. But here there is no error. Because why? This dot is exactly on the line. There is no error. These errors are called as residuals. These errors are called as residuals. Errors from the predicted line and the actual dots. Predicted line එකයි actual dot එක අතර තියෙන ඒ difference එක කියන්නේ right. නැත්නම් residual එක. මේ line එක හරියට වැටෙනවා නම් හැම ටිකක් උඩට. කිසි ගැටලුවක් නැහැ. That's very possible. But unfortunately, it doesn't happen. It doesn't happen. Right? So first of all, you have to understand what are residuals. Residuals are basically errors. Residuals are errors. What we are trying to say is whether these residuals are constant. That's what we are trying to check here. It has to be constant for the model. You will have to get one. Errors are constant math, variance is constant math. Then there is going to be a problem. So that's what we are checking here. Almost correct. Constant variance. The variance of the residuals is constant. Variance of these residuals, the errors, are constant for the moment. To understand the assumption, you first need to understand what is meant by the term residuals. To explain this, look at the black line drawn from the graph. This represents the linear model of our data. This is the linear line. That's called a regression line. We can see how well this line models our data by looking at the closely. How closely the different data points fall on the line. Right? If the data, the actual data falls on the line, there's no error. There's no resistance. The closer they are, the more accurate you want. If these dots are falling on the line or closer, then there's resistance. So that's what you have to understand. The vertical distance between the model and the our data points, the actual data points represent the error in our model. These displays are known as residuals. Each data point has an associated residual, and these play an important role in assumptions of multiple regression. So then what we are trying to say is check whether the residuals have constant variance using the residual law. So here what we are trying to do is we are going to see whether these residuals, whether these errors have a constant variance. It doesn't. So that's an assumption that we need to check. This is called homoscedastic. If it is constant, it's homoscedastic. If it is not constant, it's heteroscedastic. And it's the assumption that the variation, right, the residuals or the amount of error in the model is similar at each point across the model. Across the model, where they is similar. That's the assumption that we are trying to check. In other words, the spread of the residual should be fairly constant at each point of the predictor variance across the linear model. Right? We can get an idea of this by looking at our original scatter plot. But to properly test this, we need to draw what? We need to use a special plot has to be introduced instead. So how to do this? So this is where you can say, to test this assumption, you have to plot the standardized values as well as predicted values. I'll show you how to do that. And once you draw the plot, draw the diagram, and if it is showing like this, right? The residual plot right? To see the variance. And once you draw that, if it shows like this, there's no problem. But on the other hand, if the dots come like this, as a triangle, then there's an issue. So we have to check that accordingly. Right? Whether the residuals have a constant value or not. To check that, what you can do is you can go to data, go to statistics, linear modes and related, regression diagnostics, and residuals versus fitted plot diagram. Right? Go ahead, draw this diagram for me. Can you do that? Go to statistics, linear modes and related, regression diagnostics, and residuals versus fitted plot. So let's do that. Go to your original. Right? So if you want, you can use it for the photo data set as well. Now this is original, right? Survey for 85. Session 4 or session 3 or session 2, survey for 85. Go to statistics. Go to statistics. Then linear modes and related, regression diagnostics. And you can see residual versus fitted plot. Residual versus fitted plot. Residual versus fitted plot declare. Shall I hit enter? I'm going to click on that. And then it says, okay, residual versus fitted plot. These are very well okay. And I'm going to just press OK. So I gave it a zero, but I'm going to press OK. Right? I'm going to press OK. Then comes a nice tag. What do you see? Is it like a triangle? No, I don't see a triangle. I think it's scattered. So in that case, I could say that this assumption is made. This assumption is made. Because I don't see these dots coming as a triangle. Let's take a triangle to attention. The dots are scattered. Dots are scattered. Therefore, I could say that the assumption is made. So therefore, we could say almost constant of variance assumptions. You can see it's not like this, it's scattered. It's not coming like this, like again. So here it's scattered. Okay. So that's where you are checking what? The constant variance of residuals, which is called as what? Homoscedastic. For residuals. Errors we have to go back. Because if the errors are having a lot of variations, right, then there's a problem. Can we do the same thing for the auto data set? Auto data set is given. The auto data set is given. Auto data set. These for the satisfaction data set. So these are auto data set. They are same thing. Control statistics, linear modes are related, regression diagnostics, residual versus fitted. Just press OK, that's all. Whether a visual issue I would see it's like a triangle concentrated. So whether a catalog I don't see it as a triangle concentrated in a small area. So here also you can see there is no issue. Okay, so that assumption is what homoscedasticity assumption. Homo means what? Equal. Like an equal, constant variance. Homo to the other of zero. Taken a kata then with us the so homoscedasticity. But we are expecting the residuals to be having constant variance. Right. So that's assumption number 5. So there's no issue in both cases. Then let's go to the last assumption. Last assumption is no variety of residuals. Please take down no variety of residuals, not data. No variety of residuals. So these last two assumptions are on residuals. One, variance should be constant. Second one, the residual should be normal. Not the data should be normal, residual should be. Residual should be. Now let's see how to check residuals, whether the residuals are normal or not. For that, what you need to do is you have to draw a diagram for PP plot. Probability plot diagram. You have to draw a PP plot here diagram. So here what we will show is the PP plot, which shows the ideal situation. Right? The PP plot, you can see, look at the screen. You can see here there is a straight line. That's the expected cumulative problem. The expected problem. Then you can see the dots. The dots are observed real values of the residuals. So ideally, if the data was normal, if the residuals are normal, these dots should fall on this straight line. Residuals normal, when the expected straight line is of the horizontal alignment. Right. Then we get 4 that the residuals are normal. This straight line is a horizontal pattern. One of the dots here, residuals normal. If these dots are falling along, right, exactly on that line, the observed dots, then we call it what? Residuals are normal. When the straight line is good, හරියට මේ ඩොට් එක ලයින් වෙලා තියෙනවා Up here, residuals normal. If it is on that line. If it is not the case, then we have an issue. The residual seems abnormal. That's an issue. We need to check that. Whether the residuals are normal or not normal, we have to check it. To check that, we have to know what? The PP plot diagram. Maybe check around PP plot diagram. Okay? And how to do that? Here, you have to run these two commands. May they copy kernel run. Ready? RS standard was good with RS standard. And use this P no command. So may they copy kernel? Copy this. These two. Go to state. Make sure that you are in the first data set and paste those two commands here. It will look like this. Ready? R standard, comma R standard, T of R. You created a variable called R standard, this dual standard problem, and then T of R standard, then you plot it. So you can. What can you say? What can you say? Are the residuals normal? Yes, you can see the observed lines are falling on that straight line. Most of the cases, the observed values are falling on the straight line. So therefore, you could claim, right? You could claim these assumptions also. Then we could have entered this R here go up. Residuals are normal. Residuals are not available. The residuals are no. So I don't think there is any. We wouldn't have anything. Right. So copy this particular diagram, which I think you have file, and say, yes, this assumption is met. Why? Because the observed dots are falling on the expected dots. Expected line. Expected line equal to the answer. Right? Okay, so that's about residuals. That's about residuals. And in residuals, you are checking whether the residuals are normal and whether the residuals are having equal variance, constant variance across the model. That was the early assumption, assumption number 5, and then this is assumption number 6. Okay, so altogether we can say, except assumption number 1, which was partially satisfied, all assumptions are quite satisfied. Partially satisfied, right? Even was partially satisfied, but all other assumptions 2 to 5 were satisfied. Okay. Right. I think now, then after the break, we take another look at by looking at another example as you and work as a group. And maybe even I'll ask you how much percent. We see. Okay, so with that, then we take a small break now. Then we'll break again. Please comment. Take 12:20 a.m. today. Okay. Have a very good
Yes, Well, that's been too many. I stuck it. Interesting. Oh, you want to मेरा हाल अगर एक कोचरागට වැටෙන්නේ කියලා තමයි ඇහුවේ. යා පුල් කිය. අනිත් අනිත් බෑ
So very happy as well. Students, welcome back.
So we just finished our discussion. So we discussed about the 6 assumptions. And now let me remind you about the assignment. Did we have a discussion on assignment? We had, but let me remind you. So I have updated the guidelines, so let's see take it as well again. So please download. Right. First of all, let me explain. One point is simply taking off actual life, right? Now, let me explain the assignment PPT again. So you can go to leaf number 15. The leaf number 15, you have to equivalent book assignment guidelines. So please download it. And it updated it, so therefore I encourage you to download it. When they download it, it's right. Hope you'll be able to download it. And now I'm going to open that. Okay, so this is the assignment guidelines. So what you need to do is you need to apply, right? You need to create a synthetic data set. So for a case study, what is case study? You have developed a case study, a scenario. So it can be of your choice. Right? Scenario one would be some examples. It's an example scenario. The scenario is raised. The investors risk manage your overconfidence situation. Then studying financial literacy on spending behavior young adults. These assignment guidelines. So these have bigger type questions as well. Bigger. Then please make an amendment of your bigger type questions, 1 to 5, bigger scale perception questions, highly agree to highly disagree, likewise. Then you have to develop a question. Can be any question that you would like. So here I have again so given questions, bigger scale questions. Right, financial behavior or decisions likewise can be bigger scale. Context specific questions to that. Then deliverable, attach the questionnaire as an appendix into the scenario. Then you have to create a synthetic data set. A synthetic data. At least 2 categorical, 3 continuous, 1 binary. Let's say variable types. The bigger type. Okay, add bigger type and 1 binary. And at least, right, you can exceed this bigger type. Then ensure logical relationship between the variables. So you have to this should be in the questionnaire. There you have to create a synthetic data. What's a synthetic data set? A synthetic data set is a bogus data set. You create that data. You put your own data. You don't need to connect it. That's what we call the synthetic data set. Data. So there are here the synthetic data set means basically you need to put your own data.
and create the dataset. So that's the synthetic dataset. So you need to come up with that. And there you have to provide the each data formats as well as the Excel file. Then the fourth thing that you have to do on the individual assignment is to first check the validity and reliability of the variables, of the relevant variables. For liquor type questions, you will see in the future that I need to calculate validity and reliability. Then you have to perform descriptive analysis using scale. So key statistics like mean, median, mode, and skewness kurtosis you have to compute and you have to calculate that and create visualizations as well, like bar charts, pie charts, histograms, those kind of things. Right? The deliverable is a report summarizing findings and annotated with outcomes with screenshots. So therefore, under the individual assignment is for this required, the combined report of 1, 2, and 4. 1 is what? The DE case study. 2 is what? 2 is what? The question. 4 is what? What's those? Descriptive analysis, reliability, validity. I will tell you how to take reliability and try to come. Then you have to come up with that test, right? Descriptive analysis. Then you have to also come up with the Excel file as well as scalar data file and all. Right. So these are the requirements under the first individual assignment. Is that clear? Okay. What's the deadline? So the deadline is here. So you can see the design is the individual assignment submission design is Friday, September at 12 p.m. So you have about 3 weeks for them. Today is 15, isn't it? Record 16. So you have almost 25 days. Yeah, about 3 weeks. So it takes a significant amount of time to do this properly. So therefore start now. You have submit on that day and you don't need to present it, but I might randomly select reports and I might ask questions. So therefore, be sure that you create this and you are ready. So this is the individual assignment submission. Right? Is that clear? Clear? I will just submit. So you have to go up to what analysis? What analysis is the descriptive analysis. You have to go up to descriptive analysis. So what I say is it takes significant amount of time to do this. So I did some changes as well. So groups, maximum 6, minimum 5. Maximum 6, minimum 5. So who is the batch leader? Can you raise your hands? Batch leader? No, I got one. Yes, of course. I forgot that. So can you please send your group list to them?
You already sent the groups.
Oh, that would be thank you. So can you include don't mind the forward color here? Then will be you send it by WhatsApp or
I checked it Sony because Sony is Lanka.
or go to email negative one.
Oh,
Thank you. So then I will prepare the list and get it. Right. So that's about maximum 6 and minimum 5. Right. Then the group assignment. Let me now tell you about the group assignment. The group assignment, what you need to do is, you need to go forward. And what you can do is, within your group, take one group one, which you call, and extend it. Yeah, what you need to do is, you select one out of the group and then perform advanced analytics. Now, earlier your report stopped from there. Descriptive analysis. Now go for advanced analysis. Like what? Like t-test, ANOVA, correlation, regression, correlation. So we first put correlation analysis. Like correlation analysis, regression, multiple regression, and tested regression assumptions. Today we discussed that. Then factor analysis, which I'll be teaching you next. Non-parametric analysis, visualization, and other relevant analysis. Your structural equation for next. I'll teach you how to do structural equation modeling. Then I'll teach you smart gates. Right. Then another relevant analysis. Then what you need to do is you need to interpret the results, draw conclusions, and provide actionable recommendations based on the results, based on the analysis. And then the group report needs to be present. So this is the group report. So the group report is 10% weightage, and then there's going to be a group presentation, 20%. Right? A separate PowerPoint is not required. You present the report. Report 10%. PowerPoint optional. You don't need PowerPoint, and the group presentation will be 20%. And for the group report, these are required. Case study overview, questionnaire, data set explanation should be there. Then validity and reliable statistics you should give for the relevant variables. The key descriptive statistics, not all, but key descriptive statistics should be 8%. And then detailed methodology and analytical steps. Detailed methodology and analytical steps. So include descriptive statistics as well. And then findings with the recommendations, interpretation of the recommendations, and reflection of the group plans, how the group worked. Deliver, submit appropriate format reporting including appendices of data as marked screenshots, also data files in Microsoft Excel and data. So these also required. Data files are also required. Some students they don't submit them. That's not correct. So the group presentation, maximum 15 minutes or lesser sometimes. Content is one you have to cover. Using the report, I don't need. So I'll say PowerPoint slides are not required. PowerPoint slides are not required. So you are required to present the group report itself. So submission guidelines are given. The group submission is 30%. And then group report altogether, group report 10% for the report, 20% for the percentage. So I have given some example scenarios as well. The deadline. The deadline is, you can see, the super seven deadline is on 12 September 2025, midnight. That's a 5 days. And that's the last week that you are going to have your class. Right? Okay. So any questions? So I will again put this updated version over here. Probably updates here. Primarily it's the same thing, but again some updates are done. So I put that updates. You can download the most current version. Download the updates for your So I will delete this and I will put the most updated version there. Right. Save it. Okay, so you guys see the most updated version. Right. Then so just go through this. And ask any questions that you would have. Any questions you can ask. Then it's a one question assignment again. Let me ask you something. So that's a good idea. You ask us something. Okay. Now let's take a small case. Please. And you said under six. So under number 7. I have put a small case study. And please download it under the council. Please refresh the LMS. LMS is different. This status can small case, request instruction case study. Please download and open it.
Yeah. Right. I want you to read this case study and the relevant data set is here. The relevant data set is here. Data section 4 case study. Refresh the screen that you see there. Data section 4 case study. With the overview, please download this particular information and try to address the case study. Understanding employee satisfaction. So read the case study and try to answer the questions. Use this data set, the data data set, not the Excel file. Data section 4 case employee satisfaction report. Please download them and try to answer the case questions. Did you download it? Did you download it? Download it. Did you download it? Yeah. Right. So, just your computers and try to address the case step. Yeah. Use the data, the data base.
Yes, sir. Some of them are interplay companies, some of them are not in the standalone companies. And it's not good to sort of it's just very important things and practical things, essentially important. Practical things, don't really aspects of next, the final example could be easy, yeah. So, how about the answers? Can we see the answers? Now, randomly, let me ask questions. Students to come forward. I will randomly pick people from this and ask the topics. Go on. Yes, perfect. Let me randomly pick you and ask you to come forward and do it fast, isn't it? Motivation. Right. So let's see how to answer. Right. Let's go to the word file again. So first thing is what it says is that data set is that employee satisfaction with demographics data EDA. First of all, run so it says that yes, Franklin Tech Limited, a medium-sized IT services firm based in Colombo, recently conducted an internal survey to understand factors influencing employee satisfaction. The HR team is particularly interested in identifying actionable areas to enhance morale and retention, employee satisfaction, right? So then what they have done is they have measured these variables. What are the variables? Employee satisfaction, that's the dependent variable. So they have checked that employee satisfaction in the 1 to 5 Likert scale. These are perception-based questions. Then work-life balance, Likert scale. Management support, Likert scale. Salary satisfaction, Likert scale. Then age in years and years of experience in years. So those are also questions. Gender coded as 1, male and 0. So that information is also there. And you are the consultant research analyst to analyze the data. So the data set is there. Your task is first perform regression analysis and answer these questions. Right? So what are the questions? Right. First of all, what's the R square value? So to do that, before you do the R square, you have to open the data set, isn't it? Case study. So open the data set. So this is the data set. You can see you have the satisfaction, work-life balance, management support, salary satisfaction, employee satisfaction, age, years of experience, and testing. Right? Now let's try to run the regression. How to run the regression? Look at again the dependent variables. Here the independent variables are there, the dependent variables are there. So here dependent variable is this, and these are all independent variables. Work-life balance, management support, these are all independent variables. So then how to run the regression? Simple. You are going to, so I'm going to now give you a shortcut to run a regression, oil regression analysis. So you can go here and say regress. Same thing. If you even go and do that by using the main loops, the same thing. Regress. And then you put the independent variable, the dependent variable. What's the dependent variable? The dependent variable is employee satisfaction. So you are going to keep your cursor here. Cursor here. On histogram. So what you can do is you can keep the regress here at basically. Then you can double click on this one, employee satisfaction. Then it will come out. That's the dependent variable. Take a dependent variable. Then the independent variable. So you have work-life balance. Click this and double click. Then it will come. So that's the independent variable. Then management support, second one. Then salary satisfaction, third one. Then age. Then years of experience. And age. So always make sure that your dependent variable is indicated first. Employee satisfaction. The dependent variable should come first. And then the other independent variables. Work-life balance, management support, salary satisfaction, age, years of experience, and depth. Right? So this is how you can just give the command. On the other hand, you can go to the matrix and give that as well. When we give the method domain. And hit enter. That's all what we have to hit enter. You can see nice regression analysis has come. Did you get this? Because there are 60 observations, and the probabilities show that the regression is significant. Right. So the first question is, what's the R square value? Interpret that within the context of these studies. What's the R square value? What's the R square value? R square value is 0.95 or 96. How can we interpret that? So how many independent variables are there? 6 independent variables are there. So what it says is R square 95.6 means The 6 independent variables could explain employee satisfaction 95.6%. 95.6% of the employee satisfaction variable is explained by the selected 6 independent variables. So that's how you interpret the answer. A independent variable hiding dependent variable employee satisfaction is C this Maya explain. The dependent variable employee satisfaction is explained by these 6 independent variables 95.6%. Let's ask them. Right, let's go to the next question. What is the overall total singular? How do you know? Is the overall total singular? Check go again. But you have to check the models. How to see the model signals? Here, when you look at the you can see here the probability here is 0.0000, which is less than 0.05. In that case, you conclude what? The overall model is significant. So the answer for that is the overall model is significant. Right. Is the overall model statistically significant? How do you know? Yes, it is significant. You are looking at the probability of the F test. It is. Then hypothesis testing. Did we discuss about hypothesis? Indeed. So you can see for each independent variable, we have developed hypothesis. Right? Here you can. So we have given work-life balance. Work-life balance has an impact on employee satisfaction. So likewise, we are given. Work-life balance has an impact on employee satisfaction. Likewise, how many hypotheses do we have? We have 6 hypotheses, 6 independent variables, 6 hypotheses. Now tell me, are these now what's a hypothesis? A hypothesis is what? A testable assumption. A hypothesis is a testable assumption. So whether we can confirm this hypothesis or not is what we are trying to check now. Right? Work-life balance has an impact on employee. How can we know? Go back to the regression table and look at what whether individual significant levels are there. You can see here work-life balance has a significant impact. In that case, because it's less than 0.05, whichever the hypothesis is support. So you can see the coefficient is positive 0.916. You could say that work-life balance has a positive, significant positive impact on what? Employee satisfaction. The dependent variable is employee satisfaction. So that hypothesis is confirmed. One is confirmed. What's the second hypothesis? The second hypothesis is management support. Is management support confirmed? Management support is confirmed. Yes. There also you can see the significant value is less than 0.05. Can see it. So in that case also you could say that hypothesis also is confirmed. Okay. This is less than 0.05. That hypothesis is also confirmed. Okay, what's the next hypothesis? Salary satisfaction. Whether salary satisfaction is impacting the employee satisfaction. What do you think? Is salary satisfaction? Yes, again, there's significant impact. So you will confirm the hypothesis, you will say that hypothesis also sound. Then how about age? Is age having a significant impact on employee satisfaction? Age is a significant predictor. No. Age is not, because see here, it's well above 0.05. So in that case, We cannot call it a significant predictor. So in that case, we have to, this H4 is not support. You have to say H4 is not support. May hypothesis support rate. Because why? The sig value is less than 0.05. We don't have evidence to say that there's given impact of this 8 variable on n presence. Then about years of experience. Unfortunately, that also you can see here, the sig value is about 0.05. So they are also can say what? That hypothesis is not support. So years of experience, hypothesis also not support. H5 is not support. How about the gender? Is gender having an impact on influence? No. There also you can see it's well above 0.05. So gender also is not having an impact on presence. So this hypothesis is also not support. So these three hypotheses, H4, H5, and H6 are not support, while H1 to H3 are support. That's how you will read. So which of the variables are statistically significant? What are the variables statistically significant? These are. One, work-life balance, management support, and salary satisfaction. That's the answer. The next question, which variables are not statistically significant? That's one, age, years, and age. These are demographics, isn't it? Demographics do not play in this for these employees. Demographics do not play a role. So those are not support. What do these results imply about the influence of each variable? Those the influence for statistically significant variables, there is an influence. So what we saw is all these variables having what? A significant positive impact on employee satisfaction. So these variables, like all these three variables, which were significant, like you can see, there's a positive sign. Isn't it? There's a positive sign. Not a negative sign. Positive sign. Negative sign is that's very positive. Right? So these all have a positive sign. Okay. So that's the answer to that question. Interpretation of the coefficients. Now, interpret the coefficient of work-life balance. Work-life balance is coefficient of work. The coefficient is here. You can see the work-life balance coefficient is this. Can you interpret what's 0.916? These are all quantified Likert scale. These are measured, all these variables are measured. Right, these first three variables and given life satisfaction, salary satisfaction, and employee satisfaction are measured from quantified Likert scale. The question is, now can you interpret this 0.916? How can we interpret this? How do you interpret it? This is a real life, but thank you for attending. You know, like, after the yes, that point like answer. What I will actually you attend the answer following the regarding the last time. How do you do that? Now remember, employee satisfaction is measured in quantified Likert scale, right? Then also work-life balance, management support, salary satisfaction, all are measured in quantified Likert scale.
So in that case, you can keep this like if you increase work-life balance, if you increase work-life balance by 1 meter scale, then employee satisfaction increases by 0.916 Likert scale. अब इससे everything like that. जब variable का dependent variable है everything like that. Dependent variable है everything like ये देखिए इतना है अभी मत. ये बोलो भी. 0.196. So if you increase work-life balance by 1 Likert scale, then the employee satisfaction increases by 0.916 Likert scale. Right. Now can we implement the second one? Management support. Management support they probably if you increase management support by 1 Likert scale, then employee satisfaction goes up by what? 0.728 Likert scale. Independent variable is working right now. Dependent variable is for now, percentage if you increase by 1%, then we would say 7.72, right? The management support increases by 0.72 plus 1. If it is 100%, if you increase the management support by 100%, then you can say yes, management support, in that case, employee satisfaction increases by 72.82%. Likewise, becoming medical, because you taking on seeing medical, artificial garment material, penetrated. Right, cell satisfaction, it will be that. How can you do the cell satisfaction? If you increase cell satisfaction by 1 scale, the employee satisfaction goes up by 0.12 Likert scale. If you express it as a percentage, then you can say, for example, if you increase cell satisfaction by 100%, what is the equivalent employee satisfaction? So that's how you could interpret the coefficients. Gender interpret kara. Gender is not a significant variable, but how can we interpret the gender? Look at how gender is coded. So here there are gender coded. How is coded? What is what? What is male? 0 is female. One is male, 0 is female. Now suppose the mechanism is suppose the gender was a significant variable. How can you get that? Zero female, 1 male, right? So if you are becoming a male, what happens? One over very good. If you are becoming a male, right? What happens? You are getting your life, your work, what else satisfaction is getting out. Use there minus. Minus there's a negative impact of emission on one. That's how we have got 0 and 1. When this goes up, 0 is the base, 1 is the positive. Life satisfaction, work satisfaction was 1. But it's not significant, so we cannot use that. I asked it is silly. And you can see the coefficient is very small. So you can't think of it that way. Calculate. This is the significant. Here, what was the gender has no significant impact, a real impact on partners. Work satisfaction. You did not see. You cannot tell any impact. You will like on this comes out. In the gender, it's no problem. Gender has no impact on work satisfaction. Right. Dylan, go ahead.
Course down. Something was
Finally got it. Finally got it. Okay. Right. So we looked at policy recommendation. Now your policy recommendation. Recommend two practical HR strategies to improve employee satisfaction. Now I told you when you give recommendations only on what? Recommendations then what are variables संबंधित common. Significant variables common. Remember that very well. You will provide recommendations only based on significant variables. Here you can see only three variables are significant. What are the three variables? Work-life balance, management support, and salary satisfaction. So now your recommendations based only on those three. Age recommendations those are the three. Right? You recommendations only based on significant variables. So what kind of recommendation can you give? Increase work-life balance. What the work-life balance? Ask the people go home at 4 p.m. What if people make number again? Evaluate the other thing. Lectures what they are. Hey, other that is the regular deadline of our day. Okay. The management support. This is your management support. What does management support say? Management support. Increase the management. Give more facilities. But then salary satisfaction. Increase the salary. For today is what is not only trade is it will get not only and also medical. Then the trainees and the employees will be happy. The employees will get a increase the allowance, increase the salary, increase the monthly research. So likewise, you can provide right. Right. Now can you go prediction? Prediction can do. That's the question number 5. Your prediction. Write down the equation. The equation is substitute these values. Then you can get a predicted button. Satisfaction. You can get the satisfaction for the employee. Work satisfaction you can predict. So write down the equation. What's the equation? Satisfaction, work satisfaction equals what? What's the intercept? What's the intercept value? Intercept is 1.38. 1.38 plus 0.916 work-life balance plus 0.728 management support. Likewise, write the equation and then substitute those values. Substitute those values that were given in the list. Then you can predict. We did a prediction for what? Life satisfaction based on age and stress. We are doing the same thing. Right. Okay. Shall we now take the attendance of this? So I also discussed the more question. And then the next question is to comment on these regression assumptions. Linearity, multiplicativity, orthogonality, outliers, and things. And so we'll see whether we can do an exercise next week as well. Today there was no time. Right. Okay, with that, then we'll take attendance now. You have attendance. Let's take the results.
Thank you.